On the back of your note sheet for 26.1, you're going to see example A and example C. This is a mini lesson from our book or our curriculum. So it kind of shows you how to do the questions. So for example A, we see x to the 5th, x to the 8th, and x to the 6th power. And we need to find the GCF of those. When we're looking at variables, we want to look for the lowest power of the variable that's common to all the terms. So 5, 8, and 6, the lowest will be x to the 5th power. That's what they all have in common, or what they share. Example C, it says factor the GCF from the poly 15t cubed plus 10t squared minus 5t. So we're finding the largest term or monomial that divides into each term without a remainder. So remember, we're looking for the largest number. They all have a 5. Right? 15 divided by 5, 10 divided by 5, and 5 divided by 5 works. So 5 is a factor of all of these. And if I'm looking, I have t cubed, t squared, and t. And so they all share a t as well. So 5t is going to be our GCF. And then remember, when we're factoring it out or we're pulling it out, and we're dividing our coefficients or our numbers, and then we're subtracting our exponents. So when we factor it out, we get that answer right there. Now, to always check our work, remember, we can distribute back through. And we have a flow chart if you ever need to use it. Okay. So you're listing the coefficients of each variable term and your constant term. Then you want to find the GCF of those. Does each term contain a variable? If no, you're good. If yes, you're going to identify the lowest power or the lowest exponent. So on the bottom, below these examples, there are 3 questions that we're going to work through. Okay, so if I'm looking at my coefficients or my numbers, I have a 3 and a 2. And they don't really share a number besides 1, so I'm not going to pull out a 1. So I'm just going to leave it and move on to the variables. We have x cubed and we have x, so the lowest is just x. I didn't do anything with the 3, so I'm going to leave it. x3 minus 1 is 2, plus, leave the 2, I didn't do anything with it. X divided by x cancels each other out, or it's just 1. Okay. And again, if you ever want to check your work, like a great student would do, just distribute back through, and you should get the original question that we started with. I have 3, 9, and 27. The smallest of these 3 numbers is 3, so I'm going to start there and see if that works. 3 goes into 9, 3 goes into 27, so my GCF is 3. Now let's look at the variables. They all have an x, x squared and x. So in common, they have just one x. And then if I'm looking at the y's, y cubed, y squared, in common, they just have one y. So remember, we're dividing our numbers and subtracting our exponents. But look, I have 3xy, and I'm taking out 3xy. So those divide out and cancel, and we're just left with 1 as our placeholder. Plus 9 divided by 3 is 3. X, 2 minus 1 is 1. Y, 3 minus 1 is 2, so y squared. 27 divided by 3 is 9. X divided by x is gone. Y squared minus y is just y. Perfect. And again, distribute back through to check your answer. I want you to try this last one on your own. 2y to the fourth minus 8y cubed plus y squared. I have a 2, an 8, and then a 1, basically. So the biggest number that they share is 1, so I don't have to think about pulling that out. Now let's look at our y's here. Y to the fourth, y cubed, y squared. So the lowest would be y squared. Leave the 2, I can't divide it with anything. Y, 4 minus 2 is 2. 8, leave it alone. I'm left with 1y plus y squared divided by y squared is just 1. Okay, or remember, when we subtract these, 2 minus 2 is 0, and anything to the 0 power is 1. Or you could think that these cancel out and just become a 1. Remember, if we start with 3 terms, a trinomial, we need to end with 3 terms, a trinomial, inside our parentheses. That's another way to check our work. We're done with the note sheet, so in your book on page 386, at the bottom, we need to do the check your understanding box, questions 5 through 11. Question 5 says identify the GCF, and that's all we're doing. So look at 21, 14, and 35. The smallest of those 3 numbers is 14, so start there. If 14 doesn't work, move smaller than that. And my answer is 7. And then let's look, we have x cubed, x squared, and x. So at most, they have 1x in common. Okay. We're going to skip 10. But right now, I would like you to try 6, 7, 8, 9, and 11. You can do it. You are actually factoring it out. So make sure you pull out your GCF, and then you have what's left inside of your parentheses. (36) and 9. 9 is the smaller of those 2 numbers, so I started there, and it works. So 9 is the greatest common factor. They do not share a variable or a letter. 36 divided by 9 is 4. Put the x with it. 9 divided by 9 is 1. (6), 12, and 18. 6 is the smallest number, so it works because 12 and 18 are both divisible by 6. At most, they share 1x. So 6 divided by 6 is just 1. You can put the 1, but you don't have to. 4 minus 1 is 3. 12 divided by 6 is 2. We have an x left over, minus 3, and we're done. Go through and try 8, 9, and 11 if you haven't done it already. (25) is the smallest of these 3 numbers, and when I checked, it works. It goes into 125 and 250. And then I have n to the 6th, n to the 5th, n cubed, and so the smallest is n cubed. 125 divided by 25 is 5. 6 minus 3 is 3. 250 divided by 25 is 10. 5 minus 3 is 2. And then plus 1, because 25n cubed divided by 25n cubed is 1. Question 9, the smallest of these 3 coefficients or numbers is 3, and that works. That's the greatest common factor. And they all share an x. So we're left with x squared plus 9 divided by 3 is 3. We just have one x. 6 divided by 3 is 2. And question 11. The greatest common factor here would be 4. They share one x, and they also share one y. So 4 divided by 4 is 1. That cancels. 2 minus 1 is 1. 2 minus 1 is 1. 12 divided by 4 is 3. My x is being factored out or pulled out, so it's gone. And I have 1y left. 8 divided by 4 is 2. I have one x left, and the y is being factored out or pulled out, so it's gone. And then this whole term matches my GCF. 4xy divided by 4xy is 1. And then don't be afraid to take the time to distribute back through, which is multiply it back out and see if we get our original answer.